Imagine for a moment that the steady ticking of time, the one thing we all experience, may not be as real as we think. What if time, as we know it, is not a fundamental, universal constant, but instead an illusion? A new study suggests that time could be something far stranger, something emerging from the mysterious realm of quantum mechanics. According to the study, time may not be an intrinsic part of the universe, but a byproduct of quantum entanglement, the strange, almost mystical connection between particles that defy the classical rules of space and time. This idea doesn't just challenge our everyday experience of time, it could also help unravel some of the most significant mysteries in physics. Time is a tricky concept in physics. It's one of those ideas that feels incredibly familiar, yet is deeply mysterious when you try to understand it from a scientific perspective. In our day-to-day lives, time flows predictably, seconds, minutes, hours, and we experience it as something constant and unwavering. But in the world of physics, time behaves very differently, depending on which theory you look at. Albert Einstein's theory of relativity shows us that time can warp and stretch depending on the speed you're moving or how close you are to a massive object like a planet or a star. In the tiny world of quantum mechanics, time is even more elusive. It doesn't behave in the linear, predictable way we expect. This inconsistency in how time behaves is one of the major challenges physicists face when trying to develop a unified theory of everything. This elusive theory would combine the two great pillars of physics, general relativity, which describes the large-scale structure of the universe, and quantum mechanics, which explains the behavior of the very small subatomic particles. While each theory works perfectly in its own domain, they seem incompatible when brought together, especially in extreme situations like black holes or the beginning of the universe. Scientists have long hoped that a deeper understanding of time might provide the key to solving this puzzle. Enter the new study, which suggests that time may not be a fundamental element of the universe at all. Instead, it may be an emergent property, a result of the strange interactions between particles at the quantum level. The study, published in Physical Review A, proposes that time could be a consequence of quantum entanglement, the perplexing phenomenon where two particles, even if separated by vast distances, can instantaneously affect each other's state. This phenomenon has puzzled scientists for decades because it seems to defy the speed of light and challenges our understanding of space and time. In simple terms, quantum entanglement means that once particles become entangled, the state of one particle will be immediately tied to the state of another, regardless of how far apart they are. If you measure one particle, you can instantly know the state of the other, even if it's light years away. This strange connection is often described as spooky action at a distance, as Einstein himself once called it. The instantaneous nature of this connection seems to suggest that space and time as we know them might not be as absolute and fixed as we imagine. The researchers behind this study suggest that this entanglement could be the key to understanding time itself. Instead of thinking of time as a background or a constant that governs everything, they propose that time may be an illusion, something that arises from the interaction between quantum particles. In this view, time doesn't exist independently. Instead, it is a product of how quantum particles interact and become entangled with each other. This idea challenges the classical notion of time as a universal flowing force, replacing it with a more fluid concept that is bound up with the quantum behavior of particles. What does this mean for our understanding of the universe? If time is an emergent property of quantum entanglement, then it could explain some of the strange behaviors we see in both quantum mechanics and relativity. For example, in general relativity, time bends and stretches depending on gravity and motion. In the quantum world, time seems to lose its usual clarity, and particles can appear to exist in multiple states at once, a phenomenon known as superposition. The suggestion that time is tied to the interactions of quantum particles provides a potential link between these two realms. It could also help bridge the gap between the very large and the very small, two domains that have long defied a unified explanation. But how does this new idea about time change our broader understanding of physics? For one, it could provide a clue to the long-sought theory of everything. By rethinking time as an emergent property, we might be able to find a new framework that unites general relativity and quantum mechanics. Such a theory could explain not just the behavior of everyday objects, but also the extreme conditions found near black holes or during the Big Bang. A unified theory would be a massive breakthrough in our understanding of the universe. However, it's important to note that this is still a speculative idea. The study in question is theoretical, and it will require further research and experimentation to confirm or refute these ideas. But the very suggestion that time could be an illusion of quantum entanglement is groundbreaking. It forces us to rethink some of our most basic assumptions about reality and raises the possibility that the universe is far more interconnected and dynamic than we have ever imagined. If time is indeed not a fundamental feature of the universe, but rather a result of quantum entanglement, what else might we be wrong about? This idea doesn't just challenge our understanding of time, it challenges the very nature of reality itself. It implies that space, time, and matter might not be as separate and independent as we believe. Instead, they could be part of a much more intricate and interconnected web of interactions at the quantum level, where the boundaries between them blur and shift in surprising ways. In conclusion, the study offers a glimpse into a universe that's far stranger than we ever imagined. Time, which has always seemed like a steady, unchanging flow, could be an illusion shaped by the fundamental forces of the quantum world. If this theory proves true, it could be a game changer, not just for physics but for our entire understanding of reality. While the idea may sound far-fetched, it opens up a new frontier of thought, one that could eventually lead us to the discovery of new laws of nature and a deeper understanding of the cosmos. Time as we know it might not be what it seems, and in that mystery lies the promise of even greater discoveries.